Today class we're going to learn about the primary colors. We have red, blue, and yellow.
No, that's wrong. Those aren't the primary colors. You really screwed the pooch this time, Mrs. Santangelo. Oh no! The physics police are coming! Please, on the ground.
Listen here, all you physics nerds. MC Kirti, sickest rapper y'all have heard. Electromagnetic spectrum, the most rays we can't see. From AM to gamma, they can be harmless or deadly, but they have a unifying factor in the common speed limit. The letter C will denote this number, 3 times 10 to the 8th meter per second in a vacuum. C may have different values, different media. Sadly, we're not living in physics utopia. C equals lambda, F is what you should remember. C is velocity, lambda wavelength in meters. F is the cycles per second in hertz. After this rap, you should know this verse by verse. Now that I've killed it, Laura will take the mic. To talk about illumination, we're reaching new heights.
Kirti's rhyme sucks, so Santa Claus got the mic to teach all you peasants about sources of light. Luminous bodies emit like the sun. Illuminated bodies reflect back for fun. Luminous flux P is measured in lumens, the rate at which a light source is emitted to humans. A 100-watt bulb emits 1750 lumens, I reckon, on the surface of a 1 meter radius sphere in a second. Luminous intensity, I is next in line. Candle power and candela, I think it's about time. It's the flux of a 1 meter squared of a sphere. Intensity is equal to luminous flux over 4 pi right here. I'm just getting started, let's see what's coming next. Illuminance E is in lux or Lx. It's the amount of illumination on the radius of a sphere's surface. E is equal to P over 4 pi d squared with a purpose. Now that we've covered these measures of illumination, I've raised the roof, left the class in pure elation. Now I'm leaving this seat, give it up to Neil M. But as you'll soon find out, my rap was a gem.
What's up, y'all? It's Sir Niels Bohr. Let's go over light and matter. This physics is to die for. Transparent objects transmit light through, unlike opaque. Hey, where'd you go? Translucent objects transmit light, but it's blurry. Here comes some more, so don't worry. Colors are the spectrum of visible light. Roy G. Viv, all day and night. Now let's talk about colors, red, green, and blue. These are the primary, among others. Together, they form white light. That's the additive process. White light is the light from the sun. Sometimes two primaries can mix together. Secondary colors are a resultant of this juncture. Red and green for yellow, blue and green for cyan, blue and red for magenta, or blacks when everything's absorbed. Don't worry, no crying. Now let's get to making our rhyme. Let's learn about colors. Complementary colors together form white, man. Green and magenta, blue and yellow, red and cyan. Dyes are molecules which absorb some light and reflect like clothes, but not at night. Pigments are much larger. You can see them up close. They can be seen by the eye under a microscope, but this isn't like all of those dyes. Primary pigments absorb a color, but they reflect others. This is a subtractive process which creates normal white light. Yellow absorbs blue and reflects the others. Cyan absorbs red, magenta absorbs green. Pigments reflect one light, but the rest are smothered. Complementary pigments together form black, like red and cyan. Now I'm sending it back. To send light to its grave, let's talk about polarization. Light acts as a transverse wave. These waves are vibrating in every direction, parallel and perpendicular. This causes reflection and glare. Light passes through a polarizing film. One plane is blocked and reflected. Let's tell it goodbye. The intensity declines by half. It's polarized. The polarizing filter is called an analyzer. 2 perpendicular filters block all the light. Partial polarization occurs off a surface like a road, or when scattered by air molecules left and right. I'm out. Dude, I'm out.